All right. Yeah, review packet, page 13. Okay, so page 13. Okay, number one, helium is pumped into a spherical balloon at a constant rate of 25 cubic feet per minute. At what rate is the surface area of the balloon increasing at the moment when its radius is 8 feet? Okay.
The 25 cubic feet dVdt.
I'll write the formulas down. Those are will be
So
given
we'll
to
have
you.
it for
Yeah, yeah.
quiz.
Okay, so 25 cubic feet per minute. This is, like you said, dVdt. Pumped into the balloon, so it's positive rate. Okay, go ahead and find all the derivatives here. Hey,
It's Connie Torres, we're taking it to ask him Mr. Jones' room, but he's not here.
oh,
So we were wondering if, because at first she said your room, but then you were in a meeting.
yeah.
So she said Mr. Jones, but he's not here. We waited for
Yeah.
2 minutes.
Yeah, I think I have to continue waiting
Oh, okay.
Oh,
because I don't have to test if my meeting starts about, about like 25 minutes.
Okay.
Okay, so I just have to wait. Sorry, select. Okay, our rate is surface area increasing. We're looking for DSDT. At the moment, when the radius is 8 feet, that's nice. The 8 is given to us. We can put that in a second. And then dVdt can help us get to dRdt. Right. So, but yeah, hold on, forgot to say this. What rate is the surface area balloon increasing? Ultimately, we're looking for DSDT. Highlight that. Mm-hmm.
Would we plug in R equals 8 to dVdt,
Mm-hmm.
get dRdt,
Yeah.
and then plug dRdt and R back into that.
Yeah, so it's two-step process. We need this to get to dRdt, and then from there we can get to our answer. Place 25 in for dVdt. Place 8 in for R. Get the dRdt. Multiply this out, 64 times 4 is 256 pi. Good, divide. Pi is going to stay in the denominator.
dRdt, 20.
So now we're ready for dSdt. Replace 8 in for R. Replace dRdt with what we just found. Pi's cancel out. The rest we can just use our calculator to reduce. What's our unit of measure?
Would be surface area, so cubic feet, I meant square feet. Feet
Yeah.
squared per minute.
Okay, good. Square feet, because we're talking about surface area. Time is minutes. Okay, number 2 is similar. Let's still go to number 3. Okay, 2 cars move, start moving on the same point. From the same point, one travels south. The other travels west. At what rate is the distance between the 2 cars increasing 2 hours later? That's something to keep in mind here, 2 hours later. But I'm going to call this X, call this Y, call this Z, Pythagorean theorem. Okay, so one travels south at 60 meters per hour. So, I'm sorry. I think this is meant to be miles per hour. Okay, so M is miles. 60 miles per hour. And so, what can we put that in
So
for?
60 miles per hour south, that'd be dy dt,
Positive or negative?
positive.
Yes, because y is getting larger, right?
Yeah.
The fact that it's south has,
Farther away.
yeah. Some students though want to say down is negative, they want to say negative, but we want to look at that y value. That y value is increasing, so we want that to be positive 60. Right? 25 miles per hour.
DXDY.
dxdt.
Yeah,
Yeah,
DXD.
it's positive as well because x is also increasing as he gets further away from the starting point. Okay, at what rate is the distance between the two cars increasing? What are we looking for here?
DC.
dCdt. 2 hours later. Okay, so we got to think about how can that 2 hours later help us with the x, the y, or the z?
Oh, wait, with 2 hours later, we multiply DXDT by 2.
Yeah, so
Okay.
we're trying to take a snapshot of this triangle 2 hours into the trip. And if we know how fast these cars are moving, we know how far they will be from their starting points.
2 hours.
Yeah.
So it'd be x would equal 50, y would equal 120.
Yep, that's right, 50. Oh, can you get that? Oh, thanks. And y would be equal to 120, yep. Good. Yeah, so that's the difference here that we haven't seen before. We kind of had to, think about the problem and realize, oh wait, okay, so that's how I got to x and that's how I get to z because, or x or y, because I know how fast they're moving and I know how much time has passed. So we're on page 13 in our package. Okay, so
So
it becomes a lot easier now to find z. We can use
Right.
Pythagoras theorem, x squared plus y squared equals z squared. Okay, so now we're in the clear. Insert everything in and just make the calculator.
Sorry. Since we know that it's 2 hours later, could we just multiply C by 2, or would that not work?
Yes, yeah, we could do that.
But that probably won't
Yeah,
happen.
yeah. I think the safest bet is
It's
to
always
go through that.
back.
Yeah. But in this case, it does work. Yeah. Okay, add together, divide by 260. Okay, we're expecting a positive value, and we do get that positive value, right? As the two cars are getting further away from their starting point, we expect that z to always also be increasing. So we do get a positive rate. That distance between them is, between the two cars is increasing by 65 miles per hour at that moment in time, 2 hours later. Okay, so that's part A. Part B says ROC of area, says find the rate of change of area. So we got to find the ADT, but to find the ADT, we first have to build our area. What shape are we dealing with here? Triangle. Okay, what's the area of triangle?
That's 1.5 base. Right.
Okay, how can we adapt that to this problem?
1.5 times y.
And what's the unique feature of this derivative here that we have to use. Okay, something else? Power rule, yes.
Product rules will.
Product rule as well, yeah.
Yeah.
Yeah. X and Y are attached to each other. Okay, I'll set it up. The good news is that once you have this built, then everything you can just pull from part A because you already have everything.
So anytime the variable disappears, you put the dx dt or dy dt.
That's right. That's right. Yeah. And if there is a derivative called for it, so the G and F, we don't have d over dt's for those.
So anytime it's the derivative, so anytime it's f prime or
Mhm.
g prime.
Yeah, you should have a g over dt. Calculator.
Uh, uh,
Like, what's the unit of measure? You
would it just be miles per hour, miles per hour?
know? But area though,
That's squared.
square miles. Yeah,
Uh,
square miles per hour. Okay, so Brandon, this problem is similar to ones you've seen before with Pythagorean theorem, but the difference is that we had to take this information 2 hours later and create these two values. Because they're both starting at the same point. And one's moving at 25 miles per hour, the other's moving at 60 miles per hour. And it says, yeah, 2 hours later. So we have to imagine, what does this triangle look like 2 hours later? If we know how fast they're moving, we can kind of track their progress and understand they travel at 25 miles per hour. After 2 hours, they would have covered 50 miles. So problems like this, you're not given the X and Y values explicitly, but we have a way of getting to that answer by knowing how fast they're traveling. Okay. Let's do a street light problem here. Okay, the street light is mounted on 15-foot pole. This is a shadow problem. You know, it's a triangle within a triangle here. Okay, set up using similar triangles. Height of the small triangle is to the height of the large triangle as base of the small triangle. What's the base of the small triangle?
Y.
Good. Y is to the base of the large triangle
X.
plus 1. Okay. This is the only equation we're working with. This is easier than cones. Just clean this up. Find the derivative. Okay, derivative. 6x becomes
60x dt.
9y becomes. Okay, so as a reminder what these mean, dx dt is the rate at which the person is either moving towards or away from the lamppost, how fast he's moving. dy dt represents how fast the shadow length is increasing. And then if I add the two rays together, that tells me how fast the tip of the shadow is moving in relation to the ground. So the tip of the shadow is going to be moving the fastest because x and y are both going to contribute to how fast that tip is moving on the ground.
So divide y.
Okay, it says feet per second though. A man is walking away from the pole with a speed of 5 feet per second. So that's going to be talking about dx dt. Yeah. And he's walking away from it, so we know x is increasing. Okay. How fast is the tip of the shadow moving? We know to get to the shadow, we first have to get to dy dt. So now we can just use this equation to get to dy dt. Okay, divide both sides by 9. Okay. So we know dy dt is 10 over 3. That's the length of the shadow increasing. So the tip of the shadow is just adding the two rays together.
25 thirds.
Yeah. Okay. Final rate of change of the area.
Where do you get x dt plus y dt?
That's the formula for tip of the shadow.
Will we get that on the equation?
Yeah, but there's only 3 things you need to remember. There's the person walking, there's the length of the shadow, and then there's the tip of the shadow. You add the 2 rays together.
Read formulas on the test, please.
I'll give you volume, surface area of like geometric shapes. Okay, part B is area. I have to come back to that and get, we'll finish this up later.
Okay.
Because I have a meeting right now. But let's go into Doodle. We haven't done that for this problem yet. Okay, so I have a meeting. Try to maybe hold help session 5th period or after school tomorrow. We'll see.
Okay.
All right, thanks, guys.